Yeah, let's see this type of problems here. See, previously whatever the problems are going to be based upon whatever the properties of a inverse matrix. Same if matrix is given, how to find inverse matrix. To find inverse matrix, first we will find the determinant, then after we will find adjoint matrix. How to find adjoint matrix for 3 by 3 also we given. Based upon these two, determinant adjoint, we are going to decide inverse. But in these problems here, see, just see this problem. A square non-singular matrix satisfies some equation is given and asking A inverse. By using this equation, you have to say inverse. But given what? A non-singular matrix. What? Which one is non-singular? A is non-singular. A is non-singular means indirectly A matrix is not going to be singular. Singular means determinant of A equal to 0, then it is said to be singular. Non-singular is saying means determinant of A not equal to 0. That's why you will get A inverse. You will get A inverse for A, then by using this equation is possible to say, is asking. Very easy, this type of question is given. By seeing the question we can say answer, but I am doing here, see. Whatever just given, just we are taking that is A square minus A plus 2i equal to null matrix. I am multiplying this total equation both side with A inverse, that is A inverse into A square minus A plus 2i equal to 0 into also A inverse. Null matrix into anything is going to be null matrix only. I am multiplying A inverse inside, that is A inverse into A square minus A inverse into A plus 2 into A inverse into I. See, in properties already we said, always A into A inverse or A inverse into A always is going to be what? Identity matrix. This is our main basic definition for inverse matrix. AB equals to BI equal to I, then B is said to be inverse matrix. That B is going to be A inverse we are denoting with. If you multiply any matrix with other matrix, you are getting identity matrix, then that matrix is said to be inverse matrix and cheptunnam. That's why A into A inverse, either A inverse into A always is going to be identity matrix. Just I am modifying this is here A inverse into A square is there. That's I am writing A inverse into A. A square means nothing but A inverse A square is nothing but A into A we are writing A inverse A is nothing but what? Identity matrix into A minus A inverse into A, once again it's going to be identity matrix plus A inverse into I, identity matrix to A matrix multiplication same matrix vastadi plus 2A inverse, I am not written here, that is going to be equal to null. See now, identity into any matrix is going to be that matrix only. Here also identity matrix into any matrix is going to be that matrix. I am checking here, I want A inverse, that's why I am checking other matrices as this side, that is 2A inverse, A inverse equal to minus A is going to be plus A. This is A, identity into A is nothing but A, it is positive, you will get here negative. That is A inverse equal to I minus A by 2. That is going to be I minus A by 2. Where it is? It is going to be your answer. Same thing here. Here also same matrix is satisfying equation. A given equation is asking A inverse. Now I am multiplying A inverse inside, multiplying both side with A inverse. Now come on, A inverse into A square. A inverse into A square. A into inverse in A square is nothing but what? I into A is nothing but A. I am writing directly, just follow me right. Minus 4 into A inverse into A. What I am doing? I am multiplying with A inverse both sides. That is A square into A inverse is nothing but A. 4A into A inverse is nothing but minus 4I. 5I into A inverse is nothing but A inverse only is nothing but 0. By seeing we can say minus 5 this side, it's going to be plus 5A inverse equal to A minus 4I is nothing but, you want only A inverse, that's if you take this 5 this side, it's going to be 1 by 5, where it is 1 by 5 into A minus AI. Simply what you have to do, simply if this type of a question is giving, by seeing you can say nothing is there, simply multiplying A inverse both sides you are going to get. But for A matrix A inverse is possible or not, we have to check. A inverse when it is going to be possible? If it is non-singular matrix, that he mentioned here. Let's see other problems. Let's see these problems. Given 3 by 3 matrix is asking what is A inverse. To find A inverse, we required determinant of A and also adjoint of A. After finding adjoint of matrix, you have to divide each and every element with determinant, then you will get A inverse. That's you are going to get in as a matrix, but in the options you are having equations. After finding matrix, we have to check is it is equals to A square minus 6A plus 9I means indirectly if you substitute whatever the required values. Here A square means you have to multiply A with 2 times. Then you will get one matrix. Here you will get one matrix. Here you will get one. If you add these 3 matrices, you are going to get this total matrix. Is it is equal to that one? We have to check. It will take more time to find A inverse. Only will take more time. Finding this one, it will take more time. That's why. See, one logic is that in matrices I given when we are discussing determinant of a matrix, after properties of determinant I given one equation for 3 by 3 matrix. Equation means always equal to 0. At right side equal to 0, then we will say equation already we said. We given one equation for 3 by 3 matrix, that is what? This is 3 by 3 matrix, that is going to be started with A cube. Why? Because 3 by 3 matrix, right? See, A cube minus something into A square plus something into A minus something into I of order 3 equal to null matrix. We said already. Here in this something what? Here it is going to be trace. Here it is going to be trace of matrix. Here determinant of a matrix. Here we said what? 3 matrices determinant additions. అది మనకు ఆల్రెడీ తెలుసు ఏ matrices determinants అనేది రాద్దాం మరి ఇక్కడ ట్రేస్. వాట్ ఈస్ ద ట్రేస్ హియర్? కమ్ ఆన్, simply adding principal diagonal elements, that is going to be 2 plus 2 plus 2 is nothing but 6. Now I am finding determinant. Already you know how to find determinant of a 3 by 3 matrix. Simply, right, 1 into minus 1 is nothing but plus 1. Next 2 into 2 is nothing but what? Chapparu 8. Minus 1 into 1 once again plus 1 minus of. Next 2 into minus 1 is nothing but plus 2. 1 into 2 into 1 plus 2. Minus 1 into 2 once again plus 2 is nothing but, here it is going to be 6. It is going to be 10. 10 minus 6 is nothing but 4. Now 3 matrices determinant addition. Now come on, 3 matrices. First matrix is nothing but first row, first column eliminate just such a matrix. That is going to be 4 minus 1 is nothing but 3. Next, second matrix is nothing but second row, second column eliminate just such a matrix. Second row, second column eliminate just the matrix. 2 1 1 2. Now once again 4 minus 1 once again 3. Next, third matrix is nothing but third row, third column eliminate just such a matrix. That is once again 4 minus 1 is nothing but 3. That is nothing but 9. 6 plus 3 9. Now this is your going to be equation like previous model. Like a previous. If we know the equation, we can say inverse easily. That going to be an equation. Now come on, multiply A inverse inside both sides. That is A cube. A square into A inverse is nothing but what? A cube into A inverse is nothing but A square. Next, A square into A inverse is nothing but 6A. I will write a little bit down. Now come on, this is going to be A square. Next, this is going to be 6A. But after multiplying with A inverse arrow, total equation with 9A is nothing but plus 9I minus 4A. I is nothing but 4A inverse, it is going to be equal to null matrix. What we are doing? We are multiplying total equation with A inverse, then you will get this equation. Now you got, see how, that is minus this side, it is going to be 4A inverse equals to A square minus 6A plus 9I. We want what? A inverse. If you take 4 this side, 1 by 4, 1 by 4 into a square minus 6a plus 9a. This is minus 1 by 4, this is plus 1 by 4. It is going to be your answer. Simple, nothing is that. If you are asking by giving equation, if we ask also we will say, if we given matrix and asking equation also we can say. Like already we know the trick, we know the simplification procedure, already we know this equation. For 3 by 3 also we given, for 2 by 2 also we given. One more question here, see, whatever just by using properties we are having this question. Let's see that, that is if A is 3 by 3 matrix, then determinant of A equal to 4, then what is the argent of A determinant? Already given one property, that is what? If A is a n by n matrix, then determinant of argent of A, I given what? Determinant of A whole power n minus n. If the order of this matrix is n, then we can say determinant of argent A. That is going to be determinant of A whole power n minus 1. Already we given that also. If A is 3 by 3, why? Because our syllabus is restricted for 3 by 3. Then argent of A determinant is going to be what? Already we given, that is determinant of A whole square. For suppose it is 2 by 2 yaro, A is 2 by 2. Power order minus 1, 2 minus 1 is nothing but 1 only. That's always argent A matrix determinant and determinant of that matrix is going to be, both are going to be same. Why? Because that elements yaro. We know argent matrix for A, B, C, D, 2 by 2 matrix. If A equal to A, B, C, D, then what is determinant of, what is argent of A yaro? Simply how to interchange diagonal elements, that is A, D are going to be D, E or A, simply multiply, that is D minus B minus C, A. Simply those elements only you are going to get, same elements, minus minus is going to be plus only, AD minus BC only you will get. Simply AD minus BC is nothing but what? The determinant only. Argent of A determinant when it is 2 by 2 matrix, the determinant only. Here he given 3 by 3 matrix, order he given, we can say argent matrix, that is going to be simply determinant of A whole square. What is determinant here? 4 square is nothing but simply 16. If more than also if we ask him, we can say. If he given A and if he asking what is argent of A determinant, like this, if we given one matrix, what is determinant of argent A? No need to find argent matrix. Simply how to find determinant. Why? Because we can find determinant of that matrix very easily. In fraction of seconds you will get. In fraction of, in less than 1 minute you are going to get. Determinant find simply 3 by 3 matrix is there, you will do square only. If you are getting 2, it's going to be 4. If you are getting 4, it's going to be 16. If you are getting 5, it's going to be 25. Simply you will do, you will apply square to that determinant. Okay, let's see other problems.